In this video, I'm going to go over how to solve different types of equations besides just quadratic equations. So the first ones, we're going to be looking at these equations that involve rational exponents, which just means that there's a fraction exponent in the exponent. So if I want to get rid of it, the way you want to get rid of this is you want to raise both sides to the reciprocal of that fraction exponent. So if the exponent is 3/2, we're going to raise both sides to the 2/3 power. All right. And by doing that, we're going to have just x on this side. And I'll show you kind of what it means. So this is 125 to the 2/3 power. So you draw a radical, put the 125 in. The denominator, right? The denominator of 3 is the index, and the numerator of 2 goes outside. And you can also put it in with the 125 and make it 125 squared. I prefer this way. I think it's easier to simplify. What is the cube root of 125? That's 5, because 5 times 5 times 5 is 125. And then 5 squared gives you 25. All right, let's try this one. Same thing. I'm going to raise both sides to the reciprocal here, which is going to be the 2/3 power. All right, so we know that the left side is going to just be x plus 5. Let's do it again. Draw the 8 with a radical. The 3 goes on the index. 2 goes on the outside. The cube root of 8 is 2. 2 squared is 4. Then to finish this, we move that 5 over with subtraction. 4 minus 5 gives us -1. All right. Let's try some other ones with factoring. So there's a couple ways to do this one here. I usually teach students to move everything to one side so you can set it equal to 0. So move the 3x squared to be on the other side so it becomes a -3x squared. Then I can factor out what they have in common, which is 3x squared, which leaves me 4x squared minus 1. And this is actually an example of the difference of two squares. The square root of 4 is 2. The square root of x squared is x, and then the square root of 1 is just 1. So I have 2x minus 1 and 2x plus 1. So my three answers, all right, there's going to be three solutions here. All right, it's going to come from this first one. If I set 3x squared equal to 0, I get 0 would make that true. Then if I set 2x minus 1 equal to 0, I would get positive 1/2. And if I set 2x plus 1 equal to 0, I get -1/2. All right, let's try this one here. I actually noticed in the second one that they all have a 3 that you can factor out. So if I take out a 3, that leaves me with x cubed minus 2x squared minus 9x plus 18 equals 0. And the reason I do that is because if you can factor out that constant, right, if you were to move that to the other side by dividing everything by 3, it would cross out on the left, and on the right-hand side of the equation, it would be 0 divided by 3, which would still be 0. So ultimately, I'm going to factor this one, which I know looks different, but it's actually going to give me the same solutions as to what the original problem was. So this is where we're going to factor by grouping. You want to group the first two together and factor out what they have in common, which is x squared. That leaves you at x minus 2 on the inside. Then the next group, I'm going to factor out a -9, which leaves me with also x minus 2. All right, again, when you guys did this in Algebra 2, the idea is this needs to be the same. If it's not the same, then either you've made a mistake or you cannot factor by grouping. So I'm going to group the terms that I pulled out of each of them, x squared minus 9, and then bring down the common factor of x minus 2. This is another example of the difference of two squares or dots. So I'm going to write x minus 3, x plus 3, and then bring down that other factor, x minus 2. So my three solutions are 3, -3, and positive 2. All right, so that's how you do that one with some factor by grouping. All right, the next one says at your boards, you can try those on your own. Here, I'll show you right here. You can try these on your own, pause it so you can have some practice of doing what we just did. All right, so after that, we're going to move to some radical equations. And in this case, the first step is always to isolate the radicals. So in this case, I don't actually see anything in front of the square root, and I don't see anything behind the square root on that same left side of the equation. So actually, this is isolated. So what I'm going to do is to get rid of that radical, I'm going to square both sides. When you square a square root, those are inverse operations. So it's just going to bring down the x plus 3, no more square roots. When I expand 3x minus 1 squared, the way you want to do this is you want to take the first term, which is 3x, and square it, which gives us 9x squared. Take the second term and square it, which gives you plus 1. And to find the middle term, you multiply the two pieces together, and then you double it. So 3x times negative 1 is negative 3x, but times 2 gives you negative 6x. All right, this looks like what we did last lesson. We want to set everything equal to 0, get my everything on one side. So if I move over this x by subtraction, I get negative 6x minus x, which is negative 7x. Move over 3 and do 1 minus 3, which is negative 2. And now I'm going to factor this like we did in the last lesson. So I'm going to use the slide divide bottoms up. So I have x squared minus 7x minus 18. All right, I'm going to factor this, knowing this is technically not my answer. All right, factors of negative 18 that add to negative 7 are going to be negative 9 and a positive 2. Confirm that those multiply to give you negative 18. They do. And they add to give you negative 7. But put it over the number that you moved or slid, which is 9. And so I have x minus 1, because 9 divided by 9 reduces. 2 9ths cannot reduce, so I move that 9 in front to get 9x plus 2. All right, so my two solutions are positive 1 and negative 2 9ths. All right, so that is an example of solving a radical equation that really turned into, do you know how to solve a quadratic equation? Okay, here is another example, but this time with some absolute value equations. Kind of similar to the radicals, you want to first isolate the absolute value symbol. So this plus 8 needs to move over with subtraction to give me the absolute value of 1 minus 4x equals 5. All right, so now that it's isolated, I can set up an OR statement where 1 minus 4x equals positive 5, or 1 minus 4x equals negative 5. Because if I get it to equal to 5 or negative 5, the absolute value of 5 and the absolute value of negative 5 are both going to be 5. So that's why there's going to be two solutions here. So negative 4x equals 5 minus 1, which is 4. So this is negative 1. Negative 4x equals, we're going to subtract 1. So negative 5 minus 1 is negative 6. So reducing that gives me positive 3/2. All right, so now let's go ahead and do this next one. Same idea, I want to move the minus 2 over with addition. And something interesting happens. Get the absolute value of 2x plus 1 equals negative 3 plus 2, which is negative 1. Now you could keep going, right, and do all this work with the OR statement that we had. But if you just take a moment and think about this statement right here. We have the absolute value of something, all right, equals a negative 1. So that means whatever I plug in, I'm going to multiply by 2 and add 1. But it doesn't matter because at the end of the day, I'm taking the absolute value, which will always make it a positive. So will this ever equal a negative 1? No, there's no value that would ever make this a true statement. So this is an example of no solution. So you want to be careful when you're doing absolute value. Take a moment before you set up your OR statements that you look to see, is it actually something I can find? All right, last one, and then we'll be finished. So solving a rational equation, the first thing I do is I factor anything that can be factored in the denominator. In this case, this x squared minus 2x can factor to be x minus 2. So what I'm going to do is I'm going to multiply everything by x and x minus 2 just in the numerator. And there are a couple ways you can do this. Teachers will teach you different ways. I'm going to teach you this way, but again, there are options. So I just rewrote the problem, and I'm going to multiply everything, all three of these fractions, by just the numerator of x times x minus 2. Because by doing that, for each of these, I will cross out whatever is in each denominator. So in the first one, I'm going to cross out the x minus 2 with this x minus 2. So that leaves me with x times 3x, which is 3x squared, and x times 2, which is 2x. This one, the x and the x cross out, which leaves me with just x minus 2 times 1. So that's going to be plus x minus 2. And then the last one, you should not be surprised that the whole thing is going to cross out with that denominator because those are the same, which leaves me with just equals negative 2. So now it's one of those quadratics. We want to get everything to one side to set equal to 0. 2x plus x is 3x. All right, and then when you look at this, if I move the minus 2 to the other side with adding 2, negative 2 plus 2 is actually 0. So this is going to be my quadratic equation. Factor out what they have in common, which is 3x. These are x plus 1. So my two solutions are 0 and negative 1. Now, before you finish, make sure you take a moment and plug them back in, because you could have what is called an extraneous solution, which means that you got the answer with your work, but when you plug it back into the original equation, it gives you something that becomes an issue. Like in this case, there's going to be a 0 in the denominator. So I'm going to plug in 0. 0 is okay for the first one. 0 minus 2 in the bottom is fine. But if you look at the second one, see how that is 1 over 0? That's not going to be okay. We can't have 0 in the denominator. So this one is called an extraneous solution. All right, let's think about negative 1. Negative 1 minus 2 is negative 3. That's fine. If I put the negative 1 in that x, that's okay. Let's try negative 1 here. That's going to be 1. And then negative 1 times negative 2 is 2. So 1 plus 2 is 3. So we don't get 0 in any of the denominators when we do 1. So this one is going to be an answer. Let me change colors because you might think that is extraneous. So the only one that is actually a solution is negative 1. That is the correct solution. Okay. If you want to practice what we just did, here's some practice with a square root and an absolute value. All right, so you can try those. Here's some more practice if you want to try the rational equation like we just did. And then finally, the exit ticket if you want to try these questions. Here's the first two from the beginning. And then here are the last two. All right, good luck on this.